This is a particle representation of neutralization reaction we just discussed. HCl is the particle diagram here, and NaOH, when it combined, we will get water and sodium chloride. Okay, so now how to write the complete molecular equation, balanced equation. Let's see. So HCl, the state of matter AQ, which is dissolved in water, AQ with NaOH gives you NaCl, AQ, and water, pure liquid. So this is our molecular equation, which is already balanced. You can see that. And now let us write the complete ionic equation. So it is going to split because it is a strong acid. So H plus, Cl minus, Na plus, OH minus, and Na plus and Cl minus on the right side as product side, and water we cannot split because it is pure liquid. And now we can see the spectator ions on both sides, which is looking same on both sides, Na plus, Cl minus, and Cl minus. We are going to take those spectator ions off and we are going to write our net ionic equation. H plus plus OH minus gives you H2O liquid. That is the net ionic equation for a strong acid combines with a strong base. Here is an example for you to try and you can check the answer. You can pause the video now. Hope you got this answer. For molecular equation, you must have KOH plus HBr, both state of matter AQ, gives you KBr AQ and H2O liquid, which is our molecular equation. And then you can split it into ion K plus plus OH minus for the base and H plus plus Br minus for the acid. It doesn't matter which order you are writing, it's okay. Okay, first you can write HBr or first you can write KOH, doesn't matter. In the same way here, and you are going to get the products end to end KBr and center to center. You will get water, which is liquid. We cannot split H2O because it's pure liquid, and K plus on both sides, so that's a spectator ion, Br minus on both sides, so spectator ion. Take it off and write that. But you must have noticed again we are getting the same equation, net ionic equation. That's why any strong acid combines with any strong base, strong acid plus strong base, always the net ionic equation will be formation of water from hydrogen ion and hydroxide ion. Let's see an example of weak acid now. So when weak acid, say for example acetic acid, combines with sodium hydroxide, which is a strong base, how can we write the net ionic equation? First we have to write the molecular equation like this. So the acid is acetic acid, weak acid, which combines with a strong base, which is sodium hydroxide, gives you soluble salt and water. So this can also be written as CH3COOH. Okay, that is our acetic acid, that is our vinegar. This is an organic acid. So let's see how to write the complete ionic equation. See, we are not splitting the weak acid into ions because only strong acids can be split into ions. It's not going to completely ionize. So that's why it is weak acid. Okay. And then strong base can be ionized, Na plus and OH minus, and soluble salt can be ionized, it is AQ, Na plus and acetate ion, and pure liquid cannot be ionized. So that is our complete ionic equation. And we will write the net ionic equation by taking off the spectator ion, which is Na plus and Na plus from both sides. We are getting net ionic equation for acetic acid and sodium hydroxide. So we cannot generalize for weak acid, depends on the weak acid we are taking. But we can generalize for strong acid, the net ionic equation will be always H plus plus OH minus will give you water. This is for strong acid. See the difference? This is always same for strong acid versus strong base. But weak acid versus strong base will be different from acid to acid. Now let's see what if we have some chemical reaction like this. Can we write a net ionic equation for this one? Will there be any visible chemical change? Let's say potassium chloride. So potassium chloride, the formula is KCl. And iron nitrate, what is the formula for iron nitrate? FeNO3 twice. This is iron 2 nitrate. That will give you KNO3 plus FeCl2. Okay. So KCl, look in the solubility chart. Is that going to be soluble or not? Yes, it is, because it is in the first group. Potassium is always soluble. NO3 always soluble. So this is AQ. NO3 again always soluble. And also here double. Potassium is also always soluble, right? And FeCl2, chlorine, chloride ion. When you look in the solubility chart, iron is not an exception. So this is soluble. In this case, all are soluble and all can ionize in the solution. So how are we going to write the complete ionic equation? So K plus Cl minus plus Fe2 plus NO3 minus, but I had to write a 2 as coefficient because there are two NO3 minus, gives you K plus NO3 minus plus Fe2 plus 2Cl minus, right? Okay, so is this balanced? There are two chlorine here, so I have to put a 2 here, and there are two NO3 here, so I have to put a 2 here. So when you write the complete ionic equation, I have to write a 2, 2, and 2, and 2. Look at that. So we have our spectator ions or are spectator ions, right? So 2NO3 minus, 2NO3 minus, 2K plus, 2K plus, 2Cl minus, 2Cl minus, Fe2 plus, and Fe2 plus. Is there any net ionic equation here? I don't see any net ions, right? So we cannot write a net ionic equation for such reaction. So the chemist language is no reaction for this type of double displacement reaction. Okay, so that's how we will write for a double displacement reaction in which all salts are soluble and all the ions will float around in the solution and it will stay there. We cannot see that reaction happened. All right. Now the last type of reaction is redox reaction, oxidation reduction reaction. Let us see an example. Okay, here the reaction between zinc and copper sulfate. So let us write that equation first. Zinc is Zn. It is not a compound, so definitely that is solid. That's a metal, correct? Plus copper sulfate, so CuSO4, which is aqueous, which is dissolved in water. So you will get, it's a single displacement reaction, oxidation reduction reaction, right? So here Zn combines with the SO4 because Zn is more reactive than copper in the reactivity series. So we will get the product ZnSO4, which is Aq, can be soluble in water, copper, which is solid. So then we will write Zn is solid, so we have to just write as such that one, and copper will be ionic form, SO4 will be ionic form, will give you Zn ionic form, SO4 ionic form, and copper in the solid form. So do we have a spectator ion here? Yes, I can see SO4 minus 2, SO4 2 minus, it doesn't matter 2 minus or minus 2, it can, right? Either way. So both are cancelled out, right? So we will write the net ionic now. How can we write the net ionic is Zn solid plus Cu 2 plus gives Cn plus 2 plus Cu solid. You can see that this is an oxidation reduction reaction very clearly because Zn oxidation number is 0, Zn here it is plus 2. So that means oxidation number increases. So this is oxidation. And for copper, it reduced to 0. 2 plus changes to 0. That means that is reduction. That is why it is called redox reaction. And this is the net ionic equation for a redox reaction. So only thing is in the reactivity series, you have to look whether it is going to react or not based on this reactivity. Only more reactive metal can displace the less reactive metal from its solution. Now it's your turn. Write a net ionic equation for the reaction between silver nitrate and copper and check your answer. Okay, let us see how to write the net ionic for the reaction between silver nitrate and copper. We will get copper nitrate plus silver solid. We know nitrates are soluble, so it will be aqueous. Copper is solid, that's a metal. NO3 again, aqueous. So we will write the ionic equation Ag plus NO3 minus plus copper solid gives you copper plus NO3 minus, and we will have Ag solid, right? And then let us cancel the spectator ions and we will write our net ionic Ag plus Cu solid gives you Cu plus Ag solid. Okay, that is the answer for your try. Hope you have an understanding of writing net ionic equation now. Practice more equations and thank you for watching this video.